In this module, we will focus on the media sterilization in terms of kinetics. So we will talk about in detail about the sterilization kinetics. So that concerns the medium, growth medium or a fermentation medium that can be sterilized by filtration, if that is heat resistant. Radiations, gamma radiations are mostly used, ultrasonic treatment, chemical treatment, or heat. These are the different techniques and the possible ways by which the fermentation media can be sterilized. Practically, steam is the most, we can say, the universal way for the sterilization of the fermentation medium. But that can be only have the, when we say that if the media is heat resistant. So if that is not heat resistant, we cannot use the heat. So then the major exception is the use of the filtration. But there is a limitation when the medium for animal cell culture, because that is only the heat liable. In case of such, then the filtration is only the choice. When we say that the media is not heat resistant, that can be denatured due to the high heat, so then there is a filtration. So the filtration mode can be discussed, will be discussed in detail in the later modules. But before talking the different techniques of the sterilization, we have to focus on the sterilization kinetics. So the sterilization kinetics, so that is, as we say that sterilization, that is the destruction or the removal. When we say the word of removal, then mostly linked with the method by which we called as the filtration. But when we talk about the destruction, that is the killing, either through the moist heat. If we say that the sterilization is a process, is a reaction by which we have to kill some microorganism. We have to denature some that. So suppose if this sterilization process is like a chemical reaction, then we can say that it is the first order chemical reaction. Just you can see here this equation minus change in N is the number of viable organism present into the medium, dt is the T is the time of sterilization treatment, and K is the reaction rate constant. In this particular case, we can say that specific death rate. So it is very important at this stage that to appreciate that we are considering here not the concentration, but we are dealing with that how many number of viable cells are present. So N is basically the total number of viable cells. That is the source of contamination. So if we can say that the minimum number required for the contamination, that is the 1. So the one cell can be called as the sufficient number of cells that can lead to the contamination. Regardless from the volume of the batch, if there is a 1000 liter and there is only a one cell, unwanted cell, that is contaminated. So only the one cell is enough to create the condition which we called as contamination. When we take the integration of that equation, then we got this equation. ln is the log of nature, nt over n naught. N naught is basically those number of viable cells present at the start, and nt are those number of cells present after the treatment, and k is the constant rate. So if we plot the graph between the time and these two, as you can say here, the plot of the natural logarithm of nt over n naught against the time, then there is a straight line, as you can see here in this slide. If we just take the log, you can see if we plot the graph between nt over n naught against time, then this kind of the line we achieve. But if we just take the integration and then we plot the graph between log of nature of nt over m naught against time, then there is a straight line. So the slope of this is equal to the k, which we called as the minus k. So the plot of the proportion of the survivors and the natural logarithm, here we can say the survivors. So n naught is the total number of contaminants, and nt is the number of those viable and the contaminants remain present, which we called as the survivors in that particular medium. So by this we can calculate the k, as we have already know that what is k in sterilization kinetics. So as concerned this kinetics description makes two predictions with appear the anomalous. So an infinite time is required to have the conditions having a sterilized condition, mean 100% removal or 100% kill. So that require an infinite time. So nt is equal to 0 when there is no more survivors. So after a certain time, there will be a less than one viable cells. So if there is a less than one viable cells, then we can say there is a cell. But at that time, there will be a no viable cells. So there is something, by this sterilization kinetics, we can say that such kind of happening actually theoretically. So when there is a less than, either there will be a zero number of cells, then we can assure that our process is sterilized.